This is for Biology 223. This is homework 3 of semester 2020. It's going to be in multiple parts. I think I can do parts A, B, and C in one go. So, 6 generations of Drosophila. Drosophila are close enough to humans in sex determination, and the only twist there is that males don't undergo crossing over. That will be relevant to problems D and E for loci A and B. It won't be important for the X chromosome. So in humans, males don't undergo crossing over with the X chromosome, so that because they're hemizygous, so there's a parallel there, 10 map units. Okay, so the first thing to do here is to make sure that the genotypes of interest are labeled. A, B, and C are just about locus C and D, which is the X1. So I'm just going to label the generation 1 with their genotypes. I put the genotypes above because that keeps, I know what they are, keeps them out of the way. And then below I will treat them, I will indicate what gametes they produce, the pool of gametes. So because the first question is the probability of 5-2 being the genotype C, heterozygous at C, I only care about the ancestors as sources of gametes. So instead of keeping track of their genotypes, I'm just going to keep track of what kind of gametes they can produce. So I don't care that she's homozygous wild type. What I care about directly, I care only that she can only produce plus gametes. And for example, he's heterozygous, he's wild type X and mutant Y, but there's only a male offspring, so as far as we're concerned, he only produces a D gamete. Okay, so I'm going to do that, and in this case, I don't care about this individual, so he's a source of plus. Here we have male and female, so I have to keep track of C and D. Here only plus, here only female, so those are the gametes that can be produced by generation 1. Generation 2, then, he's going to be a male, so he can produce a plus. He only has male offspring, so I don't really care about that, actually. All I care about is the D. She will be plus homozygous wild type C, so I just have to indicate a plus. This individual will be plus D, right? He inherited the Y from the father, the male parent, and this individual can only produce plus gametes also. So far, fine. Here he's male, so he will be D, but he'll be plus, and he has a daughter, so all we really care about is the C, the X chromosome. We don't care about that. Likewise here, we don't care that he has an X chromosome because, we do care because he has a daughter, or fly daughter, whatever we want to call it. So he can produce plus and D gametes. Likewise, this individual, she now can produce plus or C at X. So she must be plus C, and you can imagine a very simple Punnett square. What does she got? She has a plus wild type from her mother, a mutant from her father, therefore she must be this. And for my purposes, if I want to think about her gametes, well, she has 1/2 chance of producing a plus and 1/2 chance of producing a C gamete. So I'm just going to show that here, 50/50, equal probability. I later will be more explicit to say 50/50. Sometimes I'll be a little bit shorthand and say 3-to-1, 7-to-1, whatever, whatever, 3-to-5, whatever ratio comes up. Here, she will inherit from each parent. Should be homozygous wild type, so she can only, and we don't care about her anyway, ignore that. So this will get a D from the father, which we're not going to care about because we don't care about individual 3, we care about the plus from the mother. Okay, so let's down to here. So her now this is something like that. So I'm going to label that was 3, 2. It's very important to keep track of this so one doesn't get confused. Let's look at individual 4, 1. So 4, 1. So individual 4, 1 has possibility 1/2 chance of wild type from the mother, 1/2 chance of mutant from the mother, and 1 chance only wild type from the father. Therefore, she will be this distribution, equal frequency of these two gametes, these two genotypes, which means I can say, okay, plus is going to be, now this is where I can say, oh, it's simple, 1, 2, 3, so I can say 3 plus is the 1C gamete, or I can say, well, plus gametes are going to be equal to the 1/2 chance of the mother times the 1 chance of the father times the 1 chance if this genotype. So the chance of that genotype is 1/2 times 1, and if that genotype, probably a gametes being plus, is 1, plus the likelihood of this genotype, which is 1/2 from the mother times 1 from the father, and then if this genotype, 1/2 chance of it plus, and I added those together, so that's 1/2 plus 1/4, so that's going to be 3/4, and you can do the same for 3, so 3/4 to 1/4. So this individual will be 3/4 plus pool of gametes representing her just as her pool of gametes will be 3/4 wild type and 1/4 mutant. Okay, that's fine. So now we're ready to solve the genotype of the individual in question, her, which is that. So let's go over here and say, well, individual 5, 2 has from the father only wild type at C, and from the mother 3/4 chance of wild type versus 1/4 chance of mutant. So there's a plus and plus homozygous wild type and heterozygous possibility, and so the probability of her being C plus is this 1/4 times 1. So that's fine. Done. Okay, related to that is the probability of question part B of 6, 2 being plus D. So heterozygous, well, I'm not going to say heterozygous, hemizygous wild type at C and mutant Y chromosome. Well, okay, so D, the Y chromosome inherited in a patrilineal fashion, mitochondria and the matrilineal. So the D must have come from the father. So can the father produce a D? Yes, because his father. So we see D, 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 D. So the possibility of D is 1 out of 1. So for him to be plus over D, he either has it from his father, from his patrilineal line, or not. And for the mother, for the plus wild type C, then the question is, what's the likelihood of the mother generating it? Well, we just looked at the probability, the genotypes of the mother, and we can say, okay, so there's 3/4 chance that, well, we can't just add them up because there's different probabilities. So let's do that differently. There's some other shortcuts, but I'm going to do it the long way here. So what's the probability of having a plus? So this is 1 out of 1 chance. What's the probability of being her represented by this Punnett square producing a wild type gamete? It's going to be 3/4 times 1 times, if this genotype, 1 chance of making that wild type, plus the probability of this genotype, which is 1/4 times 1, times the 1/2 chance if this genotype that. So that's going to be 3/4 plus 1/8. Okay, so what is that? That's 6/8 plus 1/8. That's equal to 7/8. There's some shortcut where I can do it and I just count and do it without keeping track of it. This is a safer way, and it's always keeping this out of summing to 1. So 7/8. So let's continue and see what's the probability of 6-1, that's female, being C over C. Well, we just figured out what her brother's situation, so if there's a 7/8 chance that she can produce a plus gamete, then there's a 1/8 chance, right? 1/4 times 1/2 of producing a C. So the probability of getting a C from the female parent is 1/8. So it's going to be 1/8 from the mother's side. And so we just have to calculate what's the probability of C from the father's side. But the father's plus D, so there's no chance of that. So that's a 0 chance. So that means there's no chance of 0 chance of individual 6-1 being homozygous mutant. I will stop here and continue a separate.